Hello and welcome everyone. In this session I will be discussing about alternating axis of symmetry, which we also call it as SN axis of symmetry or improper axis of symmetry. This is a secondary symmetry element. It is not a basic or the primary symmetry element, but it is a secondary symmetry element which is generated by the combination of two basic symmetry elements. Therefore, we call it as a combinatorial element, a combination element. It is a combination element. Sn is a combination of Cn and sigma h. It is a combination of a Cn and a sigma h. Suppose that Sn along Z, if it is given, Sn along Z if it is given, it is to indicate that there is a Cn along Z and sigma must be a plane which is perpendicular to this rotational axis. That plane is a horizontal plane which do not contain the coordinate which is present in the rotational axis. So within the rotational axis there is Z, therefore the horizontal plane will be xy. Suppose that I ask what is Sn along y, it is Cn along y and sigma should not contain that y. Sn along x is Cn along x and sigma should not contain x. So this is referred as combination element. Now what exactly is this element? I will define. Sn or improper axis of symmetry is an imaginary symmetry element which is a combination element where rotation operation is carried out followed by a reflection perpendicular to the rotation, or it is that element where a rotation followed by a perpendicular reflection will bring the molecule into equivalent configuration. So the prerequisite is rotation must be followed by perpendicular reflection. It is not any reflection, it is a perpendicular reflection. There should not be a parallel reflection. That means we should not use a vertical plane, we should only use a horizontal plane. Now that a question arises, should I always perform rotation followed by a perpendicular reflection or can I do the reverse? Answer is yes, we can also do the reverse. First of all, we can perform the reflection followed by a perpendicular rotation. If I choose a sigma xy, rotation must be along z. If I choose xz, rotation must be along y, and if I choose yz, the rotation must be along x, because everything is perpendicular to one another. For this reason, we also call it as rotation reflection symmetry or reflection rotation symmetry. Different names are given for this. How to understand the improper axis of symmetry? I am trying to represent it with the coordinates. As I said, it is a combination element, so any student should not do a mistake of taking only one of the operations and then check for the equivalent configuration. You should never do that. You have to perform both perpendicular operations, only then you check for the structure whether it is equivalent to the original one or not. What do I mean by it? I will give you some examples and then I will explain, but before getting into examples, you just try to understand with respect to the coordinates. First, this is a rotation along z axis and a plane is perpendicular to it. In the second case, rotation is along y and this is xz plane. In the third case, rotation is along x and this is a yz plane. So rotation has to be done first or reflection has to be done first, it is up to you, but by convention we go by rotation. So once I am doing a rotation along z, that coordinate will not exchange, but the remaining coordinates will exchange. Let me perform a C2 rotation. Just for our convenience, I am choosing a C2. You could take any of these rotations, but with respect to coordinates, C2 will be more convenient. When I am taking a C2 rotation, keep z as it is. Z is as it is, right? Now rotate by 180, y will enter into minus y, x will enter into minus x. So now minus x is away, this is minus x, z is intact and this is minus y. After 180 degree rotation, these two exchange in this way, minus x and minus y, but z is intact because we have done only half an operation. In the second case I am rotating along y, so y will be in its position, whereas x and z, they exchange with the opposite coordinates. So z will be exchanging with minus z and x with minus x. In the last case the rotation is along x, so keep x intact, x will not exchange, but y and z will exchange. So this is y exchanging with minus y, and this is z exchanging with minus z, so this will come. This is a rotation along x, therefore you just shift these two coordinates. Keep x intact. Once I have performed a rotation, that should be followed by a perpendicular reflection. Now what is the perpendicular reflection? I have already shown here. Rotation I have performed, then you have to reflect. So the reflection is through xy. Since it is passing through xy, z will come down. Minus x minus y, and after plane this is becoming minus z. So after a sigma xy plane, even z will be converted to minus z. Due to this rotation, what is happening is x is converting into minus x, y is converting into minus y. With this rotation, x into minus x, z into minus z. This is a C2 along z, this is a C2 along y, and this is a C2 along x. Okay. By passing sigma xy, then z is converted into minus z. In the next case, we are passing sigma xz. So once I pass a sigma xz, now y will exchange with minus y. And finally, with sigma yz, there is a sigma yz, x will be exchanging with minus x. Watch it very carefully now. Look at the three coordinates in the beginning. Once I have performed the complete operation means rotation followed by reflection or reflection followed by rotation. It is a combination element. X is being exchanged, y is being exchanged, and also z is being exchanged. Same is this, x, y and z are getting exchanged. X, y and z are being exchanged. So all the three will give you the same structure or the same coordinates. You can see the result. Once I have performed C2 along z into sigma xy or C2 along y into sigma xz or C2 along x into sigma yz, the answer will be the same. Every coordinate is getting exchanged with its opposite coordinate. In another terminology, every coordinate is getting inverted. You can check all the coordinates are getting inverted. So for this reason, we call this particular improper axis as equivalent to a inversion. This is a C2 into xy, therefore we call it as a S2. S2 along z, S2 along y, or S2 along x. In a simpler terminology, we call it as S2. Let it be along x, y or z, that S2 is just equivalent to inversion. Whatever structure that I am getting through inversion, you are getting the same structure when I am passing S2. For this reason, I can say that S2 is equivalent to inversion. Wherever you write inversion, definitely S2 will be present in it. Suppose I give you a molecule such as a trans hydrogen peroxide or trans 1,2-dichloroethylene. Once I have given such a molecule, when inversion is present in it, definitely S2 will be present. So for this reason, we conclude that S2 is equivalent to inversion. This is SN operation, SN improper axis. Why do we call this as alternating axis is, you can check. First, a rotation is being alternated by a reflection, and that is giving you an equivalent structure or an equivalent configuration. To get identical configuration, again perform another C2 followed by a perform another sigma xy, or perform a C2 along y, sigma xz, C2 along x and sigma yz. first combination operation is giving you equivalent, next combination operation will give you identical structure provided there is a C2. When there is C3, that will change again. And the reason for calling it as alternating axis is the rotation is being alternated by reflection. Reflection gets alternated by rotation. So one operation is being alternated by another operation. You can call it as alternating axis of symmetry. Coming to the examples, examples look very interesting. If I choose a simple BCl3 type of a molecule, is there any improper axis in it? It means you have to check for a rotation followed by a perpendicular reflection whether it is giving equivalent structure or not. Now just let me check. Supposing that I am passing a C3, 120 degree rotation, followed by a plane perpendicular to it, horizontal plane, which is a molecular plane in this case. When I pass this plane, one half which is away from you will reflect towards you, or front and back halves will reflect. Again you are getting an equivalent structure. So we can confirm that there is an SN axis and N is 3, therefore there is a S3 improper axis in BCl3. Okay, I am showing it again. You can just take the reference of one of the 3 chlorines. So if this chlorine is on top, I rotate by 120 giving an equivalent structure, but don't just stop there. It is only half an operation. SN is a combination. You have to rotate and then you have to reflect. Okay, so let's begin. I have rotated, forget about the equivalency, and then you reflect. So once you have reflected it, now you are getting a structure which is indistinguishable from the original one, and hence you call it as a equivalent structure. The same I am trying to represent on board. First let me start with a C3. This must be followed by a sigma H. Sigma H is this. Then you have to compare with the original structure. Whatever structure you get after a combination operation must be compared with the original structure. When I compare, they look equivalent. This is also equivalent, but it is a half operation. You should not consider it. Just forget about the middle operation. It is just like a transition state. Okay, these two are equivalent, therefore this is a valid operation, and C3 into sigma H will become S3. I have operated it for the first time, therefore I call it as S31. I should get an identical structure. So to get an identical structure, again I have to perform a rotation. This is a C3, I am rotating for a second time. That should be followed by a perpendicular plane. Still it is an equivalent structure. When I can call it as an identical structure means when I choose a reference which is again coming to its position, then I can call it as an identical structure. Now I am rotating it for the third time. Now we can check the structures. I have done S31, which is a combination of C31 and a sigma H. S32 is a combination of C32 and a sigma H. S33 is a combination of C33 and a sigma H. After performing a C33, whatever structure that you are getting, that looks identical to the original one, because 1 at 1, 2 at 2 and 3 at 3. But I should not compare this structure with the original one, because it is being generated from half operation. It is just a half an operation, C33. That must be followed by sigma H. Then whatever structure that I get, I have to compare it with the original one. Every one of you, whoever is watching this, you can just confirm whether it is identical or not. If it is identical, I should not perform other operations. Once you get an identical configuration, I have to just stop performing any symmetry operation. Some students think that yes, this is the identical structure because 1 at 1, 2 at 2, 3 at 3 and boron at boron, but some other students can identify it is an equivalent structure, not an identical structure, by a simple logic. The logic is you just check how many planes you have operated, plane 1, plane for the second time and plane for the third time. Any odd number of planes, any odd number of valid planes will always provide an equivalent structure. Therefore, this must be an equivalent structure. How do you confirm that it is an equivalent structure? Let's check. I have put a plus. Plus is representing front half and minus will represent back half. When I pass a first plane, once I am passing a first plane, this plus, what will happen to this plus? When I rotate it is still coming as plus, but once I am passing a plane, that is becoming minus. It means front half had been reflected back half is now reflecting towards you. Then again rotation, it is still back half. Now I pass a plane, this back half which was now towards you will reflect again away from you. So that will become plus. So back is now again coming to front. You rotate, plus will still follow. These two look identical, but this is half operation, so you should not compare, absolutely no comparison. Then I pass a plane, that become minus. This only you have to compare. Plus and minus, they are equivalent structures. It means back and front halves are exchanged with this. Okay. What do I do then? Again rotate and reflect until you get identical structure. So I am trying to rotate again. This is for the fourth time I am rotating. Every time I am numbering it, C3 for the first time, second time, third time. This is for the fourth time I am rotating. Now it is moving as minus only. Then I pass a plane. I have done up till S3 5. S3 5 means C3 5 into sigma h. Now I will take C3 6 because I am not getting identical structure. Therefore, I am continuing my operations. Okay. We have passed a plane, minus has become plus. Okay. Now here I have passed a plane, this is minus. Oh, right. This is plus. Here should be minus. Then I rotate, this is coming as minus. And finally I pass a plane. Now it is coming as plus. Then you compare the last structure with the original one. Chlorine 1 is at position of chlorine 1, plus is as plus. Therefore, this structure and this structure are identical structure. Then you can stop the operations. So, how many combination operations have we performed? We have done S31, S32, S33, S34, S35 and S36. Altogether we have performed 6 combination operations. Or 12 individual operations. 12 individual, it means 6 rotations and 6 reflections. Altogether I am doing 12 individual operations or 6 combination operations, and I am getting a identical structure. A question arises, whatever molecule that is given, depending on the principal axis or the rotational axis, should I do double the number of operations? Answer is no, you need not. Identify the rotational axis present in the improper axis. In this improper axis we have a C3. 3 is an odd number. So wherever you get an odd number, double the number of rotations will give you identical structure. Suppose that I choose PTCl4. This you can do on your own. Imagine that I am choosing PTCl4. There is a C4 and 4 C2s. I can choose a C2 and a perpendicular plane, but just for convenience let us begin with the principal axis. Choose a C4 which is pointing towards you and then pass a plane perpendicular to it. That is one combination operation. So there is a S4 in a PTCl4 molecule. There is a S4. C4 followed by a sigma H. Try to perform the operations to get identical structure. And when you do that, you will be getting S41, S42, S43 and S44. So you are doing only 4 number of operations when the rotational axis is 4. In this case the rotational axis is 3, but you are doing 6 operations. What are those 6 operations we have done? C31 into sigma H is S31. C32 into sigma H is S32. C33 into sigma H is S33. S33, it is only an equivalent structure. Then we have done S34, C34 into sigma H, C35 into sigma H, and this is C36 into sigma H. Then I got an identical structure. So I have done double the number of operations when I compare it with the rotational axis. Same number of operations when I compare it with the rotational axis. Come to a conclusion now. Whenever the rotational axis has odd number, double the number of SN operations must be performed. And whenever it is even numbered, same number of operations must be performed to get identical structure. That should give you some idea. If I show you some molecule, just imagine, okay, you can just imagine a trigonal bipyramidal molecule. This is a trigonal bipyramidal molecule. There is a C3 rotational axis in this higher fold. Along with this we also have C2s anyway, but try to take the higher fold one. C3 followed by a sigma H. There is a S3 in this. So how many times should I rotate to get an identical structure? Means I have to rotate altogether 6 times. 6 rotation operations followed by 6 reflection operations, because C3 is a odd number one. Let me choose ethylene. Ethylene has a C2 followed by a sigma H. So C2 is even number, you have to just perform even number SN improper axis, right? So that is how we have to do. I will take couple of examples. BCl3 I have done all the operations, but for the other examples I will just show where is the rotation and followed by a perpendicular reflection. I am showing ethylene for you, which SN axis is present in it. Then you can identify that there are 2 units which are eclipsed. Once you have an eclipsed units, whatever is the higher fold, whatever is the proper axis, that will continue in the improper axis also. What do I mean by it? I will give you an example. Let me perform S2 along Z. Later on let me perform S2 along Y and S2 along X. S2 along Z means it is a C2 along Z. You can check it is a C2 along Z, out of plane rotation. So 1 and 4 will exchange, 2 and 3 will exchange. This must be followed by a plane perpendicular to that. So which is the plane perpendicular to this? If this is a C2, this plane is parallel to it. This plane is parallel. This or this is just one and the same. This plane is also parallel. So YZ is parallel, XZ is parallel, XY is perpendicular. Let me choose an XZ plane. This is a, not XZ, it is XY. It is an XY plane which is a perpendicular plane. This is a C2 along Z followed by sigma along XY. What you get is above and below hydrogens get exchanged. 3 and 4 are getting exchanged. 2 and 1 are getting exchanged. In the later case, S2 along Y means rotation is along Y. Okay? Let me rotate and then we'll reflect. In the first case, right and left halves are exchanging. In the second case, above and below halves will exchange due to this rotation. So 1 and 2 are getting exchanged, 3 and 4 are getting exchanged. This must be followed by a perpendicular reflection. If this is your rotation, this is your perpendicular reflection, sigma xz. And right and left halves will exchange. Once I perform all these operations, some interesting conclusions we can draw from these structures. In the last case, it is a S2 along X, therefore the rotation is towards you. Put a dot and then show the rotation. 1 and 3 get exchanged, 2 and 4 get exchanged. Perpendicular is a molecular plane. This I call it as a sigma YZ. Every atom will be in its position because it is passing from every atom of the molecule. Now look at the most interesting things. I have performed S2 along Z, S2 along Y and also S2 along X. 3 different performances, 3 different actions. But what I am getting is the same product. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3 and 4. It means all the structures that I am generating, they are just identical to one another. All these are equivalent structures of the corresponding rotation and reflection operation, but whatever structures that I get, these are identical structures. This is equivalent to the original one, equivalent to the original one, equivalent to the original one, identical to one another. Once you perform another C2 and a sigma operation, you will get an identical structure. So within ethylene, you try to perform any S2, that will definitely provide you identical structure. So let it be S2 along X, Y or Z. Or in simple terminology, we can say that ethylene has inversion center. How can I say that it is having I? Because S2 is present. Since S2 is present, ethylene should have inversion because S2 is equivalent to I. So this is how we choose different molecules to represent the corresponding SN rotational axis. I will show a couple of molecules. Now within these molecules, you try to derive the rotational axis, improper axis, rotational axis followed by a plane. I am showing a tetrahedral molecule. You can just pause the video, draw the tetrahedral diagram and try to represent the SN improper axis present in it. Okay. Now I am giving you the reference. Hold it this way and try to get which improper axis is present in it. In the same way, you also try to do it for allene. You also try to do it for allene. Thank you.